Fascinating book, this. But of course, if it weren't for my eyes, I wouldn't be able to read a word of it. Oh, yes, I know there are ways of reading, even if you can't see, but most of us depend on our eyesight from the moment we wake up. When you think about it, we put quite a lot of demands on our eyes.
Dad, it's time to get up.
Thank you, son. Oh, that's bright. It's difficult to see clearly when the light first goes on. You've got to get used to the light. Your eyes have to adjust. I'll get some breakfast.
22 minutes to 9. Here's what you want from the
Sometimes it's difficult to read. You have to bring the thing closer or further away. And some of us wear specs. And you don't always notice what's happening around you. Pest! Why don't you go and play on your bike or something? Oh, drat, my watch has stopped. I wonder what the time is. And sometimes it's difficult to see things clearly at a distance. What time's that clock say? Being able to see clearly things that are far away, things close to you, things happening all around you, is really what your eyes were designed for. But of course, we all see differently. So do you think you could find a way of measuring how clearly you can see in all those situations? And could you compare your measurements with those for, say, your family and friends? Well, first of all, let's find out how we see. There's light bouncing off everything all around us, and that light travels into our eyes. Well, if there weren't any light, if it was absolutely pitch black, we wouldn't be able to see a thing, would we? The light travels into your eye through this black bit here, which is called the pupil. Now, believe it or not, that pupil is just a hole. Mind you, it's on the inside of your eye, and it's covered with a transparent layer. Well, I've got an eyeball down here. I'll show you. Here we are, one giant eyeball. Well, it's a model, really, and it's cut in half. Now, there's the pupil, and the bit around that, the coloured bit, is called the iris. And it's the iris that makes your eye look brown or blue or green. Now, the light goes through the hole, and then it meets this bit here, the lens. And the lens helps to focus the light onto the back of the eye here, which is called the retina. And the retina is connected to the brain. In fact, it's really part of the brain, and the brain works out what you're looking at. Your brain and your eyes have to cope with all kinds of things. Bright lights, dim lights, things very far away, things very close too. I wonder how closely I could read this newspaper clearly. Well, it's probably a different distance for each person. But how could you measure it? Well, a ruler perhaps, yes, but that's a bit awkward and you don't want to stick it in your eye. And in any case, how can you decide when it's not clear anymore? These girls think they've found a way to measure the nearest point where they can read clearly.
Good.
They're going to measure it with some thread.
Stop.
But she's moving about rather a lot. Do you think that will make a difference?
14 centimetres.
How could you make sure your measurements are as exact as possible? Is it better if your partner does the measuring? Can you think of any other ways of measuring this?
What is it? 20 centimetres.
If you're going to compare results, you'll need to record them. When you're focusing close, your eyes have to work quite hard. Well, try it. Try focusing on your finger, and then, say, the wall. Then your finger again. Can you feel the muscles of your eyes working? Can you find out all the things that are happening? Looking far away is easier for most people, but because things are further away, it's hard to see detail. For example, what's the name of that LP? What's that book called? Hard to tell. How far away do you think I could read this newspaper? Well, I'll soon find out. It was reported in Parliament yesterday that the Prime Monster... Well, it's got to be Prime Minister, really, hasn't it? That's the trouble with anything that's written, like a newspaper. You've got all kinds of extra clues. If anything seems to be wrong, your brain will correct for it. So, how else could you test how clearly you can see at a distance? One way is to mark 2 lines on a card.
Forward.
And then you try to find the furthest point at which you can see 2 separate lines clearly.
Mark it.
And then you measure it.
That's 1 metre.
Can you think of any other way to measure this?
2 metres. Forward. Stop. How are we going to measure over the tables? Never mind, we can still try.
And does it matter if you measure in a straight line or not? Joe! Put your hood back, you silly boy. That could be dangerous. You can't see properly like that. What a clot. If you're cycling, or even if you're just walking along, you need to be able to see what's happening to the sides of you. I mean, supposing somebody walked out, or supposing a car came along. Now, that's something else you could measure, isn't it? How far around you can you see when you're looking straight ahead? Well, here's one way. But how can you make sure it's fair and there's no cheating?
See it? See that one? I can see that one.
Well, these girls think they found a way.
Blue. Yeah.
But once you've found the width of vision, it's really the angle you want to measure. How would you do that? And how else could you find your width of vision? Well, there's a few things for you to measure. How close and how far away can you see things clearly? And how wide is your vision? Oh, and see if you can find out how your eyes adapt to dark and light. But whatever you do, make sure you look after your eyes because they're precious. See you.
There's a yellow there and a blue there. No. 2 blues? No, there aren't. What's it like? Horrible. It's so dark.
Now go backwards. Backwards. Keep going. Backwards. Keep going.
Is that enough? No, not yet. Yeah, that's it.
Right, can you see your hands? Yeah. Right. That one is round 15.
Yeah.